We are ready to combine empirical and molecular formula skills into one big lesson now. And I really shouldn't say one big lesson. It's not that big, honestly. You already know how to find empirical formulas. You already know how to find molecular formulas. And now we're just going to look at problems where the two skills are put together. It's just two little problems. It's really not a big deal. So just to break it down for you real quickly before you actually see the problems, the first part of each problem is going to be to use the percentages that you're given to find your empirical formula. And just as a reminder, we're going to convert percent to gram. That's really no work on your part. You just change the percent sign to a gram. Remember that you are able to do that because we are assuming a 100-gram sample. Then you're going to convert gram to mole using molar mass from the periodic table. Then you're going to look at all of your answers, find the smallest number, and you're going to divide every answer by the smallest number. Now, the goal here is to get a small whole number. We're looking for that subscript. Sometimes we'll get numbers that end in 0.5, like maybe 1.5 or 2.5, and in that case, you're going to multiply all of your answers by a 2 because we can't have half of an atom. You're going to take those numbers, write your empirical formula. Once you have found the empirical formula, you are ready to move on to the next step and find the molecular formula. Now, also in that problem, you'll be given the molecular molar mass. Sometimes that's called the experimental molar mass. That will be given to you in the problem. You are going to divide that number by the mass of the empirical formula that you just found. So you find the empirical formula and then you find its mass. It's going to be big number divided by little number. And the goal here is also to get one small whole number. That number is your multiple. You will then take that number and multiply it by all of the subscripts in your empirical formula to get the multiple of the empirical formula, which is called the molecular formula. So this would make a great page in your notes, so make sure you pause a couple times here and get all these notes written down. And now we're going to look at some problems. I think you'll be pleasantly surprised at how easy they are, and I honestly think a lot of you could do these without even seeing this lesson if you've got a good handle on the first two videos. So let's take a look at number 1. Number 1 says, calculate the molecular formula for a compound that is 13.13% hydrogen, 34.73% oxygen, and 54.14% carbon if the molecular molar mass is 138.24 grams per mole. So the first thing we're going to do here is we are going to calculate the empirical formula by using the percentages that were given to us in the problem. So the first step is to convert all of the percents to grams, and you just say, hey, I'm treating them like they're grams now, and now we're going to convert gram to mole. So we have 13.13 grams of hydrogen. Hydrogen has a molar mass of 1.01 grams of hydrogen per mole. Then we have 34.73 grams of oxygen. And oxygen has a molar mass of 16.0 grams per mole. And lastly, we have carbon. We have 54.14 grams of carbon. And the mass of carbon is 12.01 grams of carbon per mole. So again, this first step is converting grams to moles. So let's go through and figure all these up. 13.13 divided by 1.01 is going to be 12.97. So I have 12.97 moles of hydrogen. Then we have 34.73 divided by 16, and that is 2.17 moles of oxygen. And 54.15 divided by 12.01. Okay, we're going to just start that over. Having a little calculator problem here. Clear it all out. 54.15 divided by 12.01 is 4.51 moles of carbon. All right, so we've done our first main step, which is converting grams to moles. Now what we want to do is we want to look at all of our answers and ask ourselves what's the smallest, and the smallest number is that 2.17, so we will divide all three answers by 2.17. Now the goal here is to get as close to a small whole number as possible. So let's take a look at what the calculator is giving us. So 12.97 divided by 2.17 is 5.98, which is really close to 6. 2.17 divided by 2.17 is a 1, and 4.51 divided by 2.17 is 2.07, which is really close to 2. So we were definitely close enough to whole numbers. And listen, beginning chemistry students, we're always going to make this super obvious for you, so you're not going to have to look at it and think, oh my gosh, is that close enough or not? It's going to be really close, or it's going to be super close to something 0.5. So we now have the subscripts for our empirical formula. So the empirical formula is H6O1C2. Now, also, first level chemistry students, don't get too concerned with the order that these are in. Just go with whatever order they give you in the problem for now. That's really going to be all you're going to have to be concerned about at this point. We're really just looking at this point, are you getting the right subscript with the right atom? So this is the empirical formula. And I'm going to label that since I'm finding both today. Now, while I'm at it, I'm going to go ahead and figure up the mass of this because I know I'm going to need it. And I'm just going to do this in my calculator. So 12.01 times 2 is going to be 24.02, plus there's only one oxygen, so plus 16, plus 6 hydrogens. 6 times 1.01 is 6.06, so I'm going to add 6.06 to that. So the mass of this empirical formula is 46.08 grams per mole. And again, that's the mass of the empirical formula. Went ahead and found it because I know I'm going to need it for the next step. So we have found the empirical formula. Now we are going to use this mass and the molecular molar mass that they gave us in the problem to determine the multiple that we're going to use for our molecular formula. So to find the molecular formula, we will say the molecular molar mass, which is 138.24 grams per mole, divided by the mass of the empirical formula, which is 46.08 grams per mole, and 138.24 divided by 46.08 is 3. This is the multiple that we're going to use. And basically what we're going to say is that 3 times the H6O1C2. So we're multiplying it here, here, and here. So the molecular formula is H18O3C6, because remember we're multiplying those. And this is the molecular formula. So you can see, because you know just 2 basic sets of skills, it is really easy to look at that problem and calculate both the empirical formula and the molecular formula really careful. You just have to do the empirical formula first, obviously, because you're going to need the mass of the empirical formula to find the molecular formula. And remember, it's always big number over little number. The goal here is a small whole number. And honestly, for anything you see in my classes, that number is usually going to be between 1 and 4. There could be an outlier somewhere, but that's generally what you're looking at. So let's do another example of these combined. So go ahead and pause your video and copy this question down. You might even want to go ahead and try it yourself. I'm pretty sure that most of you could do this. So calculate the molecular formula for a compound that is found to be 49.8 grams of sodium, 113.6 grams of chromium, and 121.4 grams of oxygen. Now, a couple things you might notice with this, these numbers don't add up to 100 like a lot of our percentages had, and that's because these aren't percentages, these are grams. And if they give you grams right out of the gate, just go with it. So all we're going to do is just convert these grams to moles, and we're just going to carry this process out just like we've been doing from the beginning. I thought it was important for you to see a problem written this way so that if you see it later, you're not confused. You know how to do it. So we've got 49.8 grams of sodium. Sodium is 23.0 grams per mole. We have 113.6 grams of chromium. And I'm pretty sure chromium's 52, but I'm going to double check it because I haven't used that one in a while. Yep. And it says like 51.99 on the periodic table. It's universally acceptable, especially for this level chemistry. Just use 52, so that's usually what you see us using. 52 grams of chromium per mole. And we have 121.40 grams or 0.4 grams of oxygen per mole. And that's 16 grams per mole. There we go. So let's go ahead and calculate this up and see what we get. So 49.8 divided by 23 is 2.17 moles of sodium. 113.6 divided by 52 is 2.18 moles of chromium. And 121.4 divided by 16 is 7.59 moles of oxygen. Now we look at these answers and we ask ourselves, what is the smallest number? And it's this 2.17, so we are dividing everything by 2.17. And those of you who have been with me through these videos on empirical formulas, you know that this is not the only way to do it, but I love just working across and doing kind of everything in steps. There are other great videos out there that show some different methods, and they are also wonderful. Use what works for you. So this is going to be a 1. This is essentially going to be a 1. And then we have this 7.59 divided by 2.17, and that's giving me 3.49. That's real close to 3.5. That is not high enough to round up, and it is not low enough to round down. So when I look at my answers, what I want here are whole numbers, and that's not going to work because I can't have half an atom. So you ask yourself, what is the smallest number I could multiply by 3.5 to get a whole number? And you know that answer is 2. But if you multiply one thing by 2, you have to multiply everything by 2 because you've got to keep the chemical formula proportional. So it's going to be 2 sodiums 2 chromiums and 7 oxygens. So my empirical formula is Na2 Cr2 O7. And some of you may recognize that as sodium dichromate. So this was my empirical formula. And because I've got a lot going on, I'm going to label that. Now, I know that I'm going to need that mass when I solve for my molecular formula, so I'm going to go ahead and figure that up real quick in my calculator. So 16 times 7 is 112 for the total oxygens, plus 52 plus 52 is 104, plus 23 plus 23 is 46. So my mass is 262.0 grams per mole. Now I'm ready to find my molecular formula. And to find the molecular formula, I'm going to take this experimental or molecular molar mass that was given to me in the problem. I'm going to divide that by the empirical formula. Remember, big number minus little number, or I'm sorry, big number over little number, or you could say big number over what you found, the number they gave you over what you found. There's a lot of ways to look at it, but the big number's always on top. If it's not and you're getting a fraction when you divide, you've done something wrong. So 567.8 grams per mole divided by the mass that you just found, 262.0 grams per mole. Keeping those units right. Just because we're in a pandemic doesn't mean we can get slack on that, because it will eventually end and we're going to still have to be good chemistry students. So I get about 2 when I divide, and we're going to take that 2 and we are going to multiply it here, here, and here. So I'll just show that. So the 2 is going to... Here was my empirical formula. 2 gets multiplied here, here, and here. And that gives me a molecular formula of Na4 Cr4 O14. And that is the molecular formula. So that's how you put the 2 problems together. They're pretty obvious when you have a problem where you're going to need to do this, because they're going to have to either give you a set of percentages or grams for every atom represented in the molecule, and then they're going to give you this really big mass, and they're going to tell you, hey, this is the experimental mass or the experimental molar mass. And when you're given those 2 chunks of information, you know that you're going to be putting them together. Now, sometimes in chemistry, and I don't do this quite as much in high school chemistry, but I know that a college chemistry class is going to ask you, actually we're not to it yet. Before we get to that, let me give you one problem to try, and then I'm going to show you a little challenge problem, and it's actually less work. It's just a different way of thinking about it. But before we do that, I want you real quickly to do this problem, so copy it down, and then we're going to go over it together, and then I'll give you that challenge problem. I know you're all super excited about that. All right, so number 3 says, a gaseous compound is found to be 12.1% carbon, 16.1% oxygen, and 71.8% chlorine. The experimental molar mass is 395.64 grams per mole. What is the molecular formula? So let's take a look at this and see what we need to do. So the first thing I see is I've got percentages of every atom that are represented in the chemical formula. I'm going to change those percent to grams. I'm going to convert grams to moles. I'm going to divide by the smallest and get my empirical formula. So let's do that first. So I have 12.1 grams of carbon and 16.1 grams of oxygen and 71.8 grams of chlorine. So converting grams to moles, there's 12.01 grams of carbon per mole. There are 16.0 grams of oxygen per mole and 35.45 grams of chlorine per mole. And like me, I bet most of you can just rattle those masses right off because you see them all the time. 12.1 divided by 12.01 is going to be about 1. I mean, we're just going to say 1.00. It's like so close of carbon. And 16 divided by 16 is pretty much going to be 1.00 moles of oxygen. And 71.8 divided by 35.45, that should be close to 2. Yeah, it's going to be about 2.03 moles of chlorine. Now, some of you at this point could probably just eyeball this problem and figure it out, but we're going to work it all the way through. So we go through our list and we say, what's the smallest number? It's a 1. So we're going to divide everything by 1.00. Didn't matter which one you picked. I mean, they're both 1. That's going to be 1, 1, and 2 divided by 1 is essentially going to be a 2. So my empirical formula is COCl2. So this is my empirical formula. And because I know I'm going to need that mass, I'm going to go ahead and calculate that up real quick. So 35.45 times 2, there's the mass of my chlorine, plus 16 for the mass of 1 oxygen, plus 12.01 for the mass of carbon, 98.91. And we could have written all that out, and you may choose to do that in your notes, but at this point, most students can just punch that into the calculator very quickly. So now I am going to take the experimental molar mass they gave me. I am going to divide that by the molar mass of the empirical formula to get that small whole number. That's that multiple that I'm looking for to multiply by all of these subscripts. So 395.64 grams per mole divided by 98.91 grams per mole. So let's see what we get. Getting a solid 4 here. So I'm going to take that 4 and I'm going to multiply it by all of these subscripts. So 4 times 1, 4 times 1, and 4 times 2. So the molecular formula is C4O4Cl8. And again, a quick check for you. This should always reduce to this. Now you have graduated to your challenge problem. So let's see who can get this right. And like I said, it's honestly less work than any of the other problems that we have done so far. But I just want to see if you can do it. So here's your challenge. A 12.04 gram sample is composed of carbon, hydrogen, and nitrogen. Analysis confirmed that it's 7.34 grams of carbon, 1.85 grams of hydrogen, and 2.85 grams of nitrogen. What is the percent composition of each? Meaning, what percent of this compound is carbon? What percent of this compound is hydrogen? And what percent of this compound is nitrogen? So you're kind of taking your empirical formula lesson and you're combining it with your formula on percent composition. So there's your big hint. So jot that down and try it, and I'll show the answer on the next page, and I want you to see how you did. So it's a good time to pause it, try it out, and then we'll meet back up and go over the answer. All right, so since you knew the total mass of the sample, or of the compound, which was 12.01, and they gave you each individual breakdown of how many grams each atom accounts for, all you have to do is take the total mass of that atom divided by the mass of the entire compound times 100. This is nothing but percent composition. It's worded a little differently, it's presented a little differently, but what I wanted you to see was you actually have the skills to probably do a lot of things that you might not realize you know how to do. So always look at what they give you and just really ask yourself, what have they given me? Take an inventory of that. Now, what could I find from each thing? So turns out wasn't a very hard problem. And now we have our percent compositions. So we kind of work backwards from what a empirical formula problem might look like. So now you have seen how to calculate empirical formulas, molecular formulas. You've seen what they look like together, and also how you could tie this lesson in to a lesson on molar mass and percent composition. So you know a lot of stuff now. So I hope this was helpful. And if you need to see maybe some questions that are answered in different ways that you've come across, just let me know, and I'll try to get a video posted on that too.